Now, in this topic, we will see that how the resistance are connected. That is the combination of resistance. Connection of the resistance are basically two types, the series and the parallel. If we want the total resistance to increase, then we have to connect the resistances in series. If we need to find the total resistance and decrease the value, then we need to connect in parallel. That is, when the resistances are connected in series, then their total value gets increased. And when the resistance is connected in parallel, then the total value of the resistance gets decreased. So now let's see what are the series connection, what are the parallel connection. In series connection, the resistances are connected end to end, one after the another. If we talk about the series connection, then in that case, this is the first resistance. Okay. If we place another resistance one after the another, that is, they are connected end to end. So this is the connection that shows the series resistance. And we can combine any of the resistance in series. So if these resistors are connected end to end, one after the another, as if in a line, so it forms a series pattern. Next we have parallel. In parallel, the resistances are connected between the 2 points. If this is the first point and this is the second point, we say first point as A and second point as B. Then if we use 2 to 3 resistances, then in case of parallel connection, these are connected between A and B. Okay, these are the 3 resistances connected between A and B. If you want to connect 4 resistance, you can connect it like this. If you connect 5 resistance, you can connect it like this. What we will see in this diagram, that the resistance are connected between A and B. The starting point of all resistance is start from A. The ending point of all resistance ends at B. The starting and ending point remains common. So this is how the parallel resistances are connected. This is how the series resistances are connected. Now let's first start the combination of resistors in series. Now, if you take 2 resistor, 3 resistor, more than that, then we have already studied that how they are connected in series. There are some important points to consider while the connection is made in series. Let's start with it. Here we have taken 3 resistors and they are connected in series. The important point to note in this resistor is, suppose this is R1, this is R2 and this is R3. If we connect it by means of a battery, so this becomes a closed circuit and the current starts flowing in it. Now in this case, if you need to find out the total resistance, so this total resistance is found by the formula capital R, that is the total resistance is denoted by capital R. This total resistance is given by capital R1 plus capital R2 plus capital R3. So this is the formula in the case of series connection. There are 2 important things that we need to consider while dealing with the series circuit. The first thing is the potential difference. First, let's understand that how the potential difference and current is measured along the appliance if more than one appliance is connected in the circuit. First, let's talk about the potential difference. What happened? Suppose these are the 3 appliances connected, R1, R2, R3. If appliance is connected in series, so in that case, the potential difference across R1 is different. The potential difference across R2 is different. The potential difference across R3 is also different. That is, along R1, if you place a voltmeter, so it will read V1. Along R2, if you place a voltmeter, it will read V2. Along R3, it will V3. Okay, and the potential supplied from this battery is suppose capital V. That is the total potential from the battery. This capital V is given by the summation of V1 plus V2 plus V3. That is, capital V total voltage or potential difference of the electric circuit is given by the individual potential difference across each appliance. V1 is the potential difference across R1, V2 is across R2 and V3 is across R3. So in the case of series, the potential difference is given by this particular formula. Now, second is the case with current. Now what happened? This is the current flowing in the circuit. This current is capital I, that is the total current of the circuit. When it flows through the resistor, it will remain the same. It does not get changed as the V1, V2, V3 is changing. If we measure here, then it will also remain the same. That is, across series connection, the total current remains the same after passing through any appliance connected in the circuit. Now let's understand. In the case of potential difference, the potential difference gets divided when the appliances are connected in series. When the appliances are connected in parallel, then the potential difference across it remains the same. Next, understand the current aspect. When the appliances are connected in series, then the current remains the same. While when the appliances are connected in parallel, then the current gets divided into different currents. So what we have concluded, that in the case of potential difference, it will change when the appliances are connected in series. In the case of current, it will change when the appliances are connected in parallel. So now let's start with the electric circuit when the three resistances are connected in series. Okay, this is the first resistance, this is the second resistance, this is the third resistance. These are connected in series. Connect these resistance with the power supply. Okay, now let's start with the calculation part. This is the battery. This battery is supplying the total potential and the total current. So the total potential supplied by the battery is represented by capital V and the total current supplied by the battery is represented by capital I. As soon as the current is passed through this resistor, as these resistors are in series, so current remains the same. What is going to change? The potential difference. So if we need to calculate the potential difference between these 2 points, then it will become, suppose, V1. Now, if we need to find out the potential difference across these 2 points, then it will as V3. The resistances are R1, R2 and R3. Okay, now the total resistance, these are the different R1, R2, R3 are the three identical or individual resistance. If we need to find out the total resistance, then it will be denoted by capital R. And if we need to find out the total potential from this point to this point, then it will become the summation of V1, V2 and V3, which is represented by capital V. Capital V is the same potential which we supplied from the battery. As we have already seen that the total potential supplied by the battery is the summation of the potential difference across each appliance. So V1, V2, V3 is the potential difference across individual appliances, that is R1, R2 and R3. So what will be the total potential difference? That is capital V. Now see here, capital V is equals to V1 plus V2 plus V3. We know from the Ohm's law that V is equals to IR. So across resistance R1, V1 would become I times of R1. Across resistance R2, V2 will become I times of R2. Across resistance R3, V3 will become I times of IR3. Putting these value into the equation, what you will get? Instead of V, we need to place IR. Instead of V1, we are placing IR1. Same as IR2. Same as IR3. Now take I common from these three equations. What you will get? R1, R2 plus R3 equal to IR. You can cancel I from here. So what is the final answer? It would be R is equals to R1 plus R2 plus R3. So this is what we need to prove, that is, the total resistance is equals to the summation of all individual resistances in the circuit. Total resistance is capital R, R1, R2 and R3 are the individual resistances connected. Now, we have taken 3 resistance. You can take 2 resistance, you can take 4 resistance and so on. If you are taking more than 3, so you can increase it up till Rn. N is the integer from 1 to the number which you can specify, say capital N. So, this is the relationship between the resistance when they are connected in series. Now, let's see the combination of resistors when they are connected in parallel. I've already told you that when the resistors are connected in parallel, then the total resistance is decreased. It decreased by such amount that it becomes less than the smallest resistance in the circuit. Let's start with the parallel resistance. Now, what happens if we are connecting the resistors in parallel? So, they are connected always between the 2 points. This is the first resistance that we have connected. This is the second resistance that we are connecting, and this is the third resistance that we are connecting. Now, if we connect it by means of a battery, then see, there are some mathematical points that you need to consider. If first resistance denoted by R1, R2 and R3, then the total resistance in this circuit is given by, that is capital R. The formula for this is 1 upon capital R is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now, this is the formula for the resistances which are connected in parallel. Now, here also are 2 important points to consider. The first point is the potential difference. I have already told you that the potential difference is changed when the appliances are connected in series. But here the appliances are connected in parallel. That means the potential difference does not change. So, whatever the potential difference is supplied by the battery, it will remain the same. That is, if we supply capital V from the battery, then capital R also has the same potential, that is V1. R2 also have the same potential. R1 also have the same potential, that is V. R2 will also have the same potential, that is V. R3 will also have the same potential, that is V. That is, if the appliances are connected in parallel, then the potential across them remains the same. This is the point, first point, second point. So, this will become V. Okay, now for R1, V remains same, R2, V remains same, R3, V remains same. That is, in the parallel connection, the potential difference supplied by the battery remains the same for all appliances or the resistor connected. Second is the point with the current. The current does not change when the resistors are connected in series. But when the resistors are connected in parallel, then the current gets changed. Now, suppose the total current supplied by this battery is I. When this I travels and reaches this point, now see, there occurs 3 directions. One direction is this, the second is this, and the third is this. Current is need to go in which path? So, what happened? The current gets split up into 3 different directions. That is I1, I2 and I3. So, this is how the current behaves when it is passed in a parallel circuit. If there are more than 3, or if there are 2, if there are 5, if there are 6. So, the current gets split according to the branches available. If there are only 2 branches splitting, so it gets split into only I1 and I2. If there are 4 branches, then the current capital I gets split up into I1, I2, I3 and I4. So, depending on the number of branches, the current gets split into. We can also think like that current is considered as a river. When the river is flowing, and if the river will find 3 different paths, then what happens? The river does not follow one single path. The river gets divided into 3 different paths according to the passage. If the passage is narrow, the passage is wide. So depending upon the passage, the river gets split into 3 tributaries. So capital I is also a river. When it reaches this point, they see 3 different parts. So what happened? This capital I gets split up into 3 different tributaries, that is I1, I2 and I3. Now, so the total current, that is capital I, which is supplied by the battery, is given as I1 plus I2 plus I. So this is the current formula in the case of parallel. Now, what happened? After, when these current are flowing through these branches, then when they rejoin here, then the final current which emerges out again becomes capital I. So, these tributaries, when they join together into a single lane, then they again form the same river. Now, draw the diagram. The potential difference supplied by the battery is capital V and the current flowing, total current is capital I in the electric circuit. When this current passes, then it gets split into I1, I2 and I3. The potential difference across these 2 points remains the same, that is capital V. Capital I, that is total current in the circuit, is equals to I1 plus I2 plus I3. We know Ohm's law. Ohm's law states that V is equals to IR. Let's make it the formula for I, that is V upon R. If we considered I1, then it becomes V upon R1. If we consider R2, then it becomes V upon R2. If we consider I3, then it becomes V upon R. Now put these values into this equation. For capital I, we need to put V upon R. For capital I1, we need to put V upon R1. For capital I2, we need to put V upon R2. For capital I3, we need to put V upon R3. Now take common, this V is taken common and will cancel out this side. So what you will get, that 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is what you have to prove. So this is the formula for parallel resistance and this is how you need to calculate it out.